Hey gang. All right. So let's try to get this WISE stuff wrapped up here. So we're gonna crank on the WISE what is it? The lesson 7. So on the conversion setting. So this is where we're gonna go through and kind of wrap up all the details and kind of implement it into the game, but on a technical standpoint. So this is where it's not as like maybe creative, but I mean I guess that's creative in a technical way, but you're not doing a lot of sound design or mixing or anything like that. What it's now is kind of getting into the mechanics of of like optimizing it for the game. Because when you make the game, you're oftentimes going to be given a budget, and that budget is actually kind of crappy most of the time. When you think about how just as us as human beings, we're very visually oriented, meaning most of our information that comes from the world around us comes from our eyes. So therefore, if we think about that, if we kind of push that into how we allocate resources for our video games, most of the resources for the video games are going to be allocated towards the visuals, things like the gameplay and movement and all that kind of thing. So if you imagine like how much like RAM and is allocated, it's going to be somewhat depressing when you think about how much we're as audio people we're going to be given. They're going to give probably something like 90%, 95% of the resources towards the visual aspect of it, and we get about 5% of the resources, maybe at best. So that means we're talking in terms of megabytes, not gigabytes worth of stuff. Even if a game is going to take up, say, 8 gigs of RAM on a computer, we're maybe going to have maybe something like 500, 400, 300, 200 gigabytes of available data to us, which I mean, in terms of like overall scheme is can go pretty far. But when you're working with complex music soundtracks and really rich environments with lots of dialogue, the number of objects you're going to have in the game are going to get built up very quickly. So we have to really work on doing more with less. That's kind of been the name of the game since the beginning. Is doing more with less, more with less, more with less. So what we're gonna look at now is how to optimize this given a budget. So what's gonna happen is the game developer or the producer or the studio is gonna say, okay, as they're looking at overall resource, and depending on what platform you're working with. So say if you're working on PS4 or whatever, the new PS5s, I don't even know what the new specs on the newest PS5 are yet, but I imagine they're probably pretty good. But once again, when you're like, oh man, we have 16 or 32 gigs of RAM, us as audio people are going to be given a fairly small chunk of that relatively. And as games get more and more complex, we need more and more stuff to stuff in there to match the cool visuals that's going on there. So again, we have to do more with less. But if you're doing a mobile game or a downloadable game or a web-based game, what you don't want to do is have a web-based game that has like 30 megabytes of audio files in there, because if somebody's, well, especially if they're on a mobile or something like that, they have to download it. It's gonna chew up a lot of their data, and like a lot of people have unlimited data. I don't, but like if you have unlimited data, it's not a big deal, but it's a matter of speed. And so if you're like where you're someplace where you have crappy service and it takes forever to load a game, that sucks. If it's streaming from the web, same thing on a web-based game. If you're just doing something on the web, what you don't want to do is have that thing take like 30 seconds to download. People have very short patience. So the goal is using small amounts of resources so things load a lot faster. So what's going to happen is they're going to give you a budget, and then you're going to have to work within this small budget range here. So let's get into it. Let's talk about, let's actually run through this process. So let's go to Wise, launch Wise. Oops, I already did it. Let's open this up. Nope, not that one. That's the wrong one. That was lesson 6. I'll say open other. I'm just gonna go back and do it clean. Lesson 7. To update it. That works fine. And we're in. Let's save this thing. Okay, so the first thing we want to talk about is like for resource allocation is this notion of splitting up your sound banks. So by splitting up your sound banks, you're going to be able to I guess I should say, like, from the game side of things, what you do is you load the banks in as needed. So what we want to do is we want to subdivide our, like, up to this point, I guess we've been using one main sound bank for everything. But in real world, what we're going to do is we're going to have a bunch of different sound banks for either different elements or different parts or even whole different levels. And depending on the complexity of the game and how many different resource assets you need to add in there, will kind of determine how you set this up. But if we go over here into our sound banks, so right now we have no sound banks right now, or if I hit the F7, or I can also go to layouts and go to sound bank right here, we can see that we don't have any sound banks created right now. Now up to this point, what we've been doing is we just basically said new sound bank. I'll call it main. And now we see that we have a main sound bank right here, and we also can see that we have one right here. I can also create sound banks from the sound banks tab in my Project Explorer over here. So right now, if we put all of the entire game, so like this cube game is, it's a fairly simple, well, I say simple, I oversimplify it. I make it sound simple. We'll say it looks like it's an old school game, which makes me think it's simple, but it's actually, it's a difficult game to make. But it has a lot of different levels, and so those different levels have different like sound requirements. So you notice that the one that we've been playing up to this point, pretty much the general the main level that we just drop in all the time, there's no bad guys, there's no monsters or anything like that. So it would be a waste for us to be adding in all those voices of all those monsters in there. So what we would want to do is we want to say, okay, maybe we should divide this up into saying we want to have sound effects for this level, or maybe just have all, because we know that pretty much we have the same guns and weapons and jumping and human sounds and all that stuff. So maybe we have that as our main, because that's going to be true across all the different levels. And then we have another one that's going to be like monsters, and so the monsters are only going to be loaded in the monsters level. And when you're in Unity or Unreal, there's a basically you could say load the sound banks in this scene, and when you load that scene up, it loads up those sound banks. It calls on those, not dynamically. It's only when you load the game and the instance, that's when it brings it in. So you can't load and discard or kill sound banks dynamically. It's when the game is, or the scene is loaded. I won't say the game. It's when the scene is loaded. So when most of the time when you're doing like game setup, like when you're playing a video game and you load the game or load the level, you'll see the little like timer thing. That's the game loading, and that's bringing in, importing all those visual and audio assets in there. So in this case, we have this main one right here, and that's great for now. We're gonna keep it simple, but let's also add another one. So there's this other one they call the DCP, the core. Let's make another sound one for that, and the reason for that is that they've got. So I'm gonna do it from this side over here. I'm gonna do DCP underscore the, and this is determined by the game designer. That basically that's what the sound bank is going to call it. And so when they're in their WWISE or sorry, in Unreal or whatever they're doing it in, this is what they're going to be using to call this up. And this one is going to have some music in it. And so because basically right now, like in our audio events right here, we've been loading this cube main theme into all of them, but that actually this cube main theme is only played in like certain levels. So it would be a waste for us. And this one right here is actually pretty big. So what we want to do is we want to put in, and there's all these other, DCP. Actually, if we look around in here, we've got map voices, all these things right here.
Intruder alert.
Yeah. So these are some
intruder alert. Maintenance area access open.
We've got a bunch of different sounds in here that we didn't see before, like map items, signal. Let's listen to that. Sounds like some little rototom or like little toms. Strange. So what these are is these, and I don't know which ones these are all selected. Let's go back to our designer here. Or actually, yeah, that's fine. So we can see that like these are these. There's a bunch of different items in here right now, events. My bad. So I said items. I meant events. And these ones right here that say DCP. These are the ones that are going to be loaded only during the DCP event. So what we want to do is anything that has DCP right here, that is only going to be loaded on the DCP level, which I don't really understand what that means or what that's called, why they're calling that. But if we go back, and we can see that like in here we have DCP enter 2.
Drainage system access granted.
So that's going to be the DCP levels. So if we go back to our F7, and what we want to do is we want to add anything that says DCP right here, and they were kind enough to build this out so that basically this key right here tells us which sound bank to add. It can get a lot more complex when if you like your naming scheme of these things. I don't really love their naming scheme. I would come up with probably a different one, but I'll stick with it. So DCP. So anything that has DCP, we want to add that to the DCP the core, and we want to add everything else to the main one. And right there. So at this point, we have everything is now in associated with a sound bank. And the music one before was in the main, but right now they have the DCP. Where's the DCP music? Right here. So the DCP music, if we go back, DCP music is cube main theme, and also they put the heartbeat in that one right there. Interesting. It's a little strange. I wonder why they did that. So that one's going to be pushed in the music, and that's because that one's probably loaded up at the start. That's strange. I wonder why they did the heartbeat in that one. I feel like that's because if you're in a level that doesn't use DCP music, then that's going to be a problem because you won't be able to hear the heartbeat. So strange. I don't know if that was an intentional thing or not. So I don't know. Did they have? Well, we did it on map loaded before, didn't we? No, they did a stop all on map loaded. Because I feel like that's where it should go on map loaded is where we should do the heartbeat thing. But that's okay. That's how they decided they want to do it. So I'm gonna stick with it. Okay, so back at our F7, our soundbank editor here. This is the important what we want to look at right here. So what's going to happen is they're going to give you a budget, a data budget. And then right now it's set to infinite. So what we want to do is we want to set this to main, and I think what we want to do is we want to set the main one to 9 million, which is 9 megabytes. I gotta count 1, 2, 3, 4, 5, 6. So 9 million there, and we'll do 6 million on this one. So that means we have a total budget of 15 megabytes for the game right there, and which I mean seems like I don't know. It's hard to determine what that actually means because these files are super small and just cut up, and you know we don't have a sense of scale on this thing. So what we need to do is our goal is we need to get underneath this thing right here. So right now it says max size and free space because we don't actually have any data size yet because we haven't generated our sound banks. So what we need to do is let's go ahead and generate our sound banks. I'm gonna go to my user settings and override the. Whoops, not that one. Let's get this set up for not the Mac one. I'll just worry about the Windows one really. Let's go do this. And also because you know if you're working on like a whatever a Nintendo Switch or like handheld devices, they're gonna have a little bit less. They're gonna have less resources than say either desktops or like console games. But even console games have a fixed amount of memory, whereas if you work on like a desktop computer, like on Windows or something like that, it's hard because you don't know how much RAM there's going to be. So you basically can assume that probably these days everyone's got a minimum of 8 gigabytes of RAM. Maybe not, but you should say that. And so whatever the system specs say that like this is the recommended settings or the minimum settings that you need, you're like you need to have 8 gigabytes of RAM, and of that 8 gigabytes. So when you say 8 gigabytes of RAM, that's also a little misleading because you're like, well, that's 8 gigabytes of total system memory. And of that, maybe our game needs to take up 5 gigabytes of that because we need 3 gigabytes for just Windows to run and all the background processes, and especially if people are running like 50 tabs in like Google or like in Chrome or something like that, then that's going to be a problem. So you're going to run out of system resources, but you do have to be kind of conscious and aware of that. Okay, let's get into Audio Kinetic, WWISE, Cube, Sound Banks, Windows. You'll see I still have an OG in there. That's still the original one from the very, very beginning, just so that I always have the original to fall back on. You can actually create versions of this. So if you're like, oh, I like that one. It's probably not the best idea to do that, but I just want to do this so I can get back to the original state. Mac doesn't really need to be there, but that's okay. I'll say select folder. I'll do the same one for Mac just so I can update that one. Because the reason that this is important is that I select Mac, select folder. That when you're going to be turning your projects in after this, you're going to be turning in your sound bank, and I want your sound banks folder that includes both Mac and the Windows, so that whoever's using it can drop that folder right into their system and listen to it. But we'll get to that later. Say okay, and let's generate all. So I could just select if I want to select those guys. If I hit generate all, it automatically selects everything for me. But I'm gonna say generate all. Cool. So we got some warnings down here. These little yellow things, and they're telling us, hey, there's something wrong here. But it says soundbank mean exceeding specified memory size. Both of those are exceeding the memory size for both Mac and Windows. So we get 4 errors right there. If we look up here, indeed, we see that this is a problem. So and that other window gives you a little bit more granular detail. This one just gives us a bunch of red right here. So if you're working with multiple different platforms, so if I'm working with Mac, Windows, and also like Switch or I don't know, like a bunch of some of these other ones in here, it's harder to tell what's going on here. But right now it's telling us that we have a budget of 6 million and a budget of 9 million right here, and we're the decoded side is 11 megabytes. So this is 9 megabytes. So we're wrong here, and then we're way off on this one right here. We have 20, like basically we have a budget of 6 megabytes, and we're at 30, almost 30 megabytes. So that's the real world problem. So let's go address this and see how we can actually bring these things down. So what we want to do is there's a couple different things. We can look under our share sets right here, and we can look at our conversion settings. So our conversion settings, let's go back to my designer window right here. This is our default conversion settings right here. And this is how everything is running right now. So I double click on that and it shows us this is how it's going to be default. So in other words, the original format is going to be PCM. Actually, let's go back over to my audio and look at this for a moment. So you'll see that everything is white. That means it's since been converted. I should have looked at it before. A lot of this would have been blue. So we can say that this has been converted. But if we look at the conversion settings, what it did, so if I select whatever on weapons, for instance, right here, and I go to conversion, it's saying using the default conversion settings right now. So if I want to know what that is, I can hit the edit right here, or I can go back over into my my share sets and look at it there. But so if I open this up right here, this is what it's actually converting it to and from. So what we're seeing here is that these are we want to look at how we can reduce our file sizes. So we have a number of different strategies. Number one, we can actually cut down and trim those file sizes. And so this is where we can go, okay, let's trim off the fat and and get rid of like all this extra sound that we don't need to use. But maybe we're at that point already with our sound design and our editing. We're like, we can't get rid of any more sounds. So the next step is to go, okay, well, right now this is what's coming in. We say Mac, it's coming in as input. So we can actually reduce it. So if it's stereo, we can convert it to mono, but right now it's as input. But if we look at these original channels right here, this is the column that shows everything we have. Oh, those one haven't been converted yet. All of these are 1.0, meaning it's a one channel input. So we don't really it's mono input. So nothing is stereo, but we could go from mono to stereo or stereo to mono, and that reduces our file size by 50%. Because obviously for that one, not overall, but for that one sound effect, because we're reducing it down to one channel. We can remixing, we can do sample, we can change the sample rate. So we can see the sample rates on these right here. There's some sample rates of 22.05, 11.025, 44.1. So it's kind of divisions of 44.01. But let's see what they've got on here. So like the pig runt is down here, and it's basically 11.025 kilohertz. So that means it's going to have like the Nyquist frequency is going to be about 5,000 hertz. So the highest frequency this thing can kick out is about 5 or 6 kilohertz, 5.5 kilohertz. So that's okay, but that makes a really file size. I'm not going to force the sample rate here, and this is how you can adjust the sample rate right here. But this is the biggie right here. So this is our PCA. This is we're running at full wave uncompressed, and we're probably all well aware of what perceptual coding is. But perceptual coding is basically the idea that you can remove. They model the human ear and get rid of it, get rid of anything that the human can't perceive. There's a lot of things that happen in terms of time and in terms of frequency and amplitude that mask other frequencies. So the most common one that we know of is MP3, right? MP3 has been around forever, but it's a licensed version. Fraunhofer Institute owns the rights to MP3, so it basically you can't just make MP3 without paying a license. So you can decode it for free, but you can't encode it for free. Although a lot of us do. Technically, there's supposed to be some money channeling up back to Fraunhofer Institute. So let's look, rather than look at this window right here, let's create a new share sets over here. So I'm going to go into, for right now, I'm going to go into, let's do weapons here for a moment. Let's, my weapons, yeah. So we're on weapons right here. So instead of this one, we want to create a new share set, or actually, I guess I could do it here. So I want to create a new one right here, a new conversion settings. I'm going to call this SFX. And what that did is that created a new share. So if I look under share sets and a conversion settings, we see I could have done that also over here. That I have an SFX right here. So now what I want to do is I want to say, so you can say use share sets or define custom. Basically, I want to say use the share sets of this. You can also define a custom version of this one right here. And yeah, let's just go edit and take a look at this thing. So now what we're looking at this is now I create a new conversion settings, and it's showing everything right here is in blue. And right now we're just looking at the weapons, I think is what we have set up right now. I think that's all I wanted to do is work on the weapons one, right? And yeah, so we're going to work on just the weapons at this point. And so what you can do is you can create multiple different conversion settings. So maybe you want to convert all the dialogue differently than you do the sound effects, because maybe you want dialogue to be crystal clear because that's a big part of your game. But weapon sounds are maybe not a hardcore part of your game, or maybe ambient sounds, maybe have an ambience background one, and you can lo-fi that because it's going to be, you're walking through fields with crickets and birds and chirping and stuff like that. But and maybe if that's a big part of the game, you want to emphasize the high fidelity of that, then you actually create that as high quality. But you can also reduce that significantly. So you can create multiple different share sets, or like some convergence settings in your share sets for different kind of groups of sounds. So let's go back into this one right here, and looking once again at this. Now this one, these haven't been converted under this new conversion setting right here. So we look at this, and I'm not going to change any of this, but now under the format, that's what I want to look at right here. So we have 80 PCM. So 80 PCM is like adaptive PCM. So if you remember what PCM audio is, if you don't remember, it's basically uncompressed wave, where it's basically just a gigantic grid, and it's every sample, it tells it what height or what amplitude to be, which then when it plays it back, it sounds like sound to us. 80 PCM it's called adaptive. It's kind of like basically it takes a dot and it says just add one, or just add the difference from the previous value. And so it's kind of a crappy way. It's an old school algorithm of doing data compression. I don't like it. AAC, we've seen AAC. So AAC is like essentially the codec that runs inside of MP4. I'm not really going to go into that right now, although if you select it, it's pretty interesting. I've not tried using AAC. I'm curious about this one because I think this is essentially the new version of MP3. This is the evolved version of MP3. When we say MP3, it's actually MPEG-2 layer 3. Then we have MP4, but MP4 is fundamentally different than MP3 because MP4 is a container that contains video and audio. And inside that audio, you can have different codecs. And so this is the AAC is what runs inside of MP4. So you could use this one right here, but I'm going to use Vorbis. So Opus and Vorbis are made by the same company. It's not a company, it's a collective. It's actually open source. I've not tried the WEM Opus. I don't know what that is. So we call this one Og Vorbis. And it comes from a name of a sci-fi character. I can't remember exactly the history of this thing, but the character's name was Og Vorbis. It's OGG Vorbis. And so you'll see the term Og and you'll see the term Vorbis sometimes used. But basically, you can think about it like an open source MP3. That's kind of the idea. So there's this kick-ass crew, and I'm brain farting on the name right now, but they're amazing people that are working their asses off making cool stuff. So they do this thing called Vorbis. So they create Vorbis, which is, like I said, an open source MP3. So I love it. I think it's great. It's really cool. It's used heavily in the game industry. You can also just encode it like out of stuff. So when you export out of something like Ableton, oftentimes you can choose MP3 if you wanted to. But like in a lot of the Wavelab and some of the software that I use actually has Vorbis output, so you can actually stream Vorbis. You can use Vorbis. It's a great tool. Like VLC can read it. It's pretty cool. So I want to choose both these to Vorbis right here for both platforms, and it's a little bit different though. When we think about MP3, we talk about MP3s in terms of kbps, kilobytes per second, the data rate. You choose between like 128 to 320 or whatever you want to. But Vorbis works a little bit different. It has just a quality setting right here. And it's kind of weird because it goes from -2 to 10. And you can choose the quality setting that you want right there. And so what that does is it's because you can think about MP3. It's like, so it's a VBR MP3, variable bit rate of MP3. So it doesn't constrain it. So it's a little harder to tell how much it's going to be. So I wonder if we could do advanced right here. So, okay, so 4 is about 64 bit. It's about 64 kilobits per channel. So if I move this up and down, I can go, and I guess it's a float. So you can go all the way up. So it's 250 kilobits per second for this conversion, but we can go all the way down to -2, which is 16 kilobits per second, which that's going to sound like ass. We're not going to do that. Let's stick with 4. 4 is like middle of the road, and you could always start with it there and experiment with it. Experiment with it from there. You can also just adjust it here. So I can adjust the levels here. So we'll just stick with it at 4 right there for both of these. So Vorbis is going to be, that pretty much is industry standard. Vorbis being this. Opus right here, that's for doing voice. So Opus is also by the same group that does Vorbis, but it's usually intended for voice stuff. Vorbis works fine for voice as well for video games, but I would say by and large just stick with Vorbis. That's a good one to use. Okay, so now we've got that set up, and let's say convert. I'm gonna check for Mac and for Windows. Say okay. Blast through all those, and those went from blue to white. And we can see now the original channel, or converted channel, original sample rate, converted sample rate. So nothing changed there because we kept all fixed. But here's what's interesting. We look at the original size and converted size. So the R launch for the rocket launcher, it was 67.9, and now it's 9.9, and now it's a 6.8 to 1 compression ratio. Now remember, this is data compression. This is not audio compression ratio. So It talks about the duration and bandwidth right here. That's like, I mean, that's useful. It's useful when you're just looking at this. You're like, what's taking up so much time? These are all really short. But if you see something there that's like a minute and a half, you're like, wait, whoa, what's going on? So it's a good like help you out there. But I think it's interesting to look at the size ratio right here. If you scroll down, I mean, it's crazy. We're getting like 10.4 to 1 compression ratio. So it was 274 kilobits or kilobytes, and now it's 26.4 kilobytes. That's a massive reduction in data. And if we look over down here, we're getting like on some of these, what is that? Shotgun shells, concrete. We're getting like 20.4 to 1 compression ratio. That's insane. So we went from like 20, or yeah, where was it? 142 kilobytes to 7 kilobytes. We just squeezed this thing way down. That's awesome. So this is one of our strategies. So let's go back over and look at our sound banks here. I'm going to hit generate all again. Boom. So now we see that in here, our budget was 9 megabytes, and now our our data size is right here. It's right here. It's 8, but then when it's playing back, it decodes. It's like you could say that this is the playback like size of this thing, but the data size in your RAM is 8 megabytes right there. So that's perfect. So we're just on there. So we have whatever zero point 0.8 megabytes of buffer right there. So it's pretty tight. So the problem is if I go back and I add a bunch more sound effects in there, that could be a real problem. So we're gonna run into some snags right there. So well, I guess we'll address that here in just a minute. But one of the things is as you convert these things, and part of it is we convert all the sound effects, and if we go back to our audio, and now we can see that of course everything is white, so everything's been converted. It may not be the case for some of these other ones. I don't know if we find any blue ones in here, but let's see if we can find any blues. No, but let's go back to our normal general settings one. And if I want to listen to something, so if I listen to the rocket launcher, actually we can do it from our launch down here, or one of these, whatever, rocket launcher. Let's do explode mini. So right now we're listening to the original one, and so we can go, okay, I understand what the quality of the sound is. That I can hit original, turn that off, and now I'm listening to the encoded version of it. See if we can hear the difference. I gotta put my other headphone in. I can't hear. It's hard to talk with these headphones in. Sounds about the same to me. So that's within range. The reason being, I would consider these explosions and stuff kind of lo-fi to begin with, but you want to go through with critical ear and listen to before and after the encoding, make sure that it's right, because you might have to tweak your settings. You're like, ooh, we compressed that one a little bit too hard. Want to back that off. But also you could start experimenting and ratcheting up your compression ratios or your quality value. So in other words, you're bringing down your quality value will increase your compression ratio on your Vorbis stuff. It looks like AAC does that too. I've not tried it with AAC. And you can experiment to listen to it before and after. So the thing is, if you don't have the original selected right there, and it's well, I guess no, I guess it should work all the time. Sometimes there's been cases where I have to, like, if you're getting something that's not playing, you sometimes have to toggle this on and off to get it to play. But after it's encoded, you should be able to hear both before pre-encoding and post-encoding. Now, like I mentioned, we're pretty close on our budget right here. So one of the ideas is that we can we're like, well, that's a little too close for comfort. Maybe I'm like, well, the producer's like, can you add a few more, whatever. We want to add a different theme music in there that's going to be bigger. You're like, ah, crap, I got to change that up. So this one's still screwed up. But we'll address that one here in a minute. So because we only worked on, because our sound effects were part of the weapons. So weapons were in the sound effects, and basically everything that was sound effects got squished down in that bus. But it was actually, we just did weapons, right? Yeah. So all we did was compress the weapon stuff. So there's the DCP core stuff, the stuff that wasn't in weapons, or wasn't in the weapon stuff hasn't been converted. So that like DCP the core, all these things at the top here have not been converted, or they converted, but it's not working right. But what we want to do is, if we're going through, we're like, man, you know what? Playing the game, we can actually reduce this down some. So if we look at things like our random containers, It could be both well, in this case, probably in the weapons section and maybe in the main character section. What do we have here? We don't have any, there's no random containers there. No randoms, no randoms. Those are all just actor mixers. So in this one right here, so if I pull up something like die, that's only got 2. Jump, that's 4. Pain, well, that's actually probably a little bit ridiculous. And in footsteps here, we could actually go more granular. Remember, if you recall, before we had a bunch of footsteps in here, and we disabled a lot of those. But what we can do here is in pain and jump, those look like they have a lot. So, like, if we listen to pain for a minute. So there's 7 different pains. Does the game really need that many different pains to actually feel realistic? So what we can do is we can reduce these right here or take those out. Maybe actually just take out, let's take out 3. Yeah, take out 3 of those and take out a couple of these. And now when I do this, the jump is only going to do random between these 2 and these 2 here. The cool thing is it stays in my session, but it doesn't render those to the sound banks. So as I'm developing and I'm experimenting with this, I can try say, okay, is this acceptable? Like how many can I pull out of here and make it acceptable so it still sounds like it's it's diverse enough in sound? You're like, well, maybe instead of having 8 different panes, I can go with 4 different panes and adjust more of the randomization and the pitch and the speed and some of that kind of stuff, and also with volume to give it more variation through other avenues than just having a whole separate sound file. Because by doing this, I just reduce my sound files by even further. So if I go back and I generate my sound, generate all again, it went down even further. What did I do there? Should have gone down further, but it looks like I have less. I can't remember what it was before. I feel like it was less. Must have done something funny there. But basically, now I've rendered those out. But the cool thing is if I want to bring them back in, all I have to do is just say, wait, well, I want more jump, just to give a little more variation right there. I want to see if it goes down or up. That's weird. It went down. Oh no, my free space went down. Yeah, that's right. That makes sense. Okay, so adding that jump back in, my free space went down and my data rate or my data size went up. So that's correct. Cool. Okay. So now what we want to do, we want to look at this one right here. So we've got a problem here, and we look in here and say what's causing all the problems in here. One of the issues that we can deal with here, and it was actually if in previous sessions it was already set up this way, but this one they went back and kind of undid that effort. But if I go back to my designer view and let's look at the cube main theme right here. The one that we haven't really talked about this one before, but there's this stream button right here. By selecting this stream, what it does is it streams it from the hard disk instead of loading it into RAM. And there's some pretty big advantages. So if you're dealing with something like the stream, like actually, how long is this thing? It's like, whatever, it's like 2 minutes and 10 seconds. And stereo. So that's a big file. And the thing is, when you're talking about your computer's ability to draw up resources, like to call up things, we can either load it into RAM. So if we think about what RAM is basically your temporary memory. And whereas your computer or your hard drive is your long-term storage. And it used to be when you have spin drives, or some of you still have spin drives. I still have spin drives for like my big data stuff, but my system runs on SSDs these days most of the time. So SSDs are pretty much as fast as RAM, and they're not as fast as RAM, but they're very quick compared to the old days. So back in the old days, though, if you wanted to call up, like, say you wanted to play something like in Ableton, and you wanted to play some drum sounds, if you wanted to try to play those drum sounds from the hard disk, and it used to be these spinning platters. It was almost like a record player. It's like a spinning platter with a little head that tracks across, and you remember you can still hear it, when this drives spin down, or when, like, if you drop, what you don't want to do is drop a spin drive while it's running, and you can actually, those heads hit, they actually, the heads, the drive is spinning and those heads float above because of the air pressure of that. They actually float above the drives. But if you have them touch, it's like having a record player that floats above, where the needle floats above the record. And what you don't want to do is have it touch, because if it touches, it scratches the surface, and that's where you lose data, and that's where you have to go to these expensive recovery houses, and it gets really bad. But But when you would play like a snare drum, it would have to track over, find that snare drum, read the data from that, and then pass that up to the computer. And that takes a long time, especially if you have a lot of stuff going on. That little head has to track all over the place, and it was very difficult for it to do that. So it takes time. So there's a latency involved with that. So it makes sense for us to load things like samples and also game sounds up into RAM, where it's near instantaneous. So when it's basically in random access memory, it's solid state memory instead of a physical memory that basically can just draw that up very quickly. Nowadays with SSDs are essentially like longer term storage RAM, but they do have a limited read write cycle, and they're not as fast as RAM. But so when we want to do a lot of complex sounds, we want to load those into RAM. But for things that are like don't need a lot of recall speed and where latency is not an issue, we can draw those from the disk itself. Back in the old days, actually, in fact, with CD-ROM days, we would put CD-ROMs in, and I used to play games that would have the audio would it was an audio CD, and so like it was a audio. They call it yellow book CDs, but there's two different layers. One section was the game, and the other section was the audio later, and it was actually just full streaming audio CDs from that. It wasn't very dynamic music, but it sounded fantastic. So, and in fact, some games you actually had the ability to drop in your own. You could put in your own CDs, and you could have your own soundtracks to games. So like there was a game called Homeworld back in the day that I used to play, real time strategy space game, and I used to listen to these like couple like it was the Nine Inch Nails Fragile record. So even still gives me chills when I listen to that record. It makes me feel like I'm alone in space flying around. It's really crazy. So but so we used to be able to do that in the old days, but nowadays we basically it's pulled from SSD. So SSD is really quick, but it's still we can what that allows us to do is put resources into the game, but that don't need to be in the RAM. And so by streaming this, it means pull it from the disk, not from RAM. And that basically says it doesn't use up any resources of your actual your game management. So if we go back, so by putting this just the music to stream, and we go back to here, let's generate all, boom, that puts us under budget by quite a bit too. Not quite a bit. I'm sorry, half a megabyte. But out of 6 MB, that's pretty good. So now we're where we need to be. I should note though that when those turn red, that's not a limit. It's not gonna hard limit you from working with that. It's just a visual reminder. So you can still generate, you can still play. It's not saying it's not the error is not, hey, I can't play the game. It's like, yeah, the game's gonna work, but you're over budget, and that's that. When you get to the game producers, they're gonna get cranky at you for going over your budget there. So those are a couple of those strategies how to squish stuff down, and so it's a combination of both using clean, creating multiple sound banks, squishing stuff down with the right thing, and also upstream when you're doing sound design. So if you're creating like your assets, so maybe you're making gun sounds, like whatever, you're starting from scratch and you're creating gun sounds for this game. What you need to do is those gun sounds should never be in stereo. So in your DAW, in your session, we're gonna do this next week. In your DAW session, you're gonna actually want to like make those as render those as mono, and when I say mono, I mean one track, one audio track, not dual mono. So some DAWs, depending when you say export as mono, it just basically sums the left and the right to be the left channel and the right channel. So it's dual mono. We want actual mono. So, and you can take care of some of that if you accidentally export it as stereo and it's to dual mono. You can take care of that in conversion settings here, but it'd be cleaner to do upstream from there. Then other things, of course, are trimming your file sizes down. Other ones are like if you look for like long repeating sections, say like the teleport or the heartbeat. Remember the heartbeat right here. Like if we look at this, so right now that's 30 seconds of heartbeat that's repeating itself. So we could actually trim that way down. Maybe take two of those if there's a little variation between the two of those, and that's going to reduce our file size a lot. Or anything that you can do to repeat. So trim stuff down, that anything that's looping or repeating, trim that way down. And then reducing data using smart sound banks and doing good compression algorithms and good sample rate management will allow you to really squish this down and sound really good at the same time. So those are the kind of strategies that we're looking for with reducing this down. So the next thing we want to look at here is this processor optimization. When we are we have like when we think about how these sounds are triggered, we want to kind of keep the chaos to a minimum as possible, because even though it's not a ton of processor compared to what the visuals are doing, they do eat up cycles. And what happens if you sit there, if you have a sample of a machine gun that's like the sample's like we'll say a half a second, it's going brrrr, some like crazy like oh god, what's the spinning guns? I can't remember what the spinny guns, you know, like the where you like can blast through like ammo like in like a heartbeat. So maybe each one of those. So each time it fires, it's going to like what is that called? Oh man, it's killing me. But basically you're gonna blast through like a crap ton of ammo in a second. So what's gonna do is it's gonna fire every single time the gun fires, it triggers that sample. But the problem is if your sample is say even 0.2 seconds long, it's going to load up and it's going to be playing something like 400 voices at exactly the same time. And because the tail of each one of those is still playing, and that eats up a lot of memory, or not memory, but CPU cycles. And so that can be a real problem. So what we want to do is we want to manage how many sounds are actually playing at the same time. Or the thing is, if you're in a melee, basically running around and you're in some battle and all the bad guys jump in, or maybe you are commanding like 10 units and you're going up against a bunch of other players that have 10 units, and all of a sudden you have like 70 80 units on the scene, and you're trying to do sound effects between dialogue, footsteps, foley, all that. All of a sudden these sound effects just build up, and there are tons of them. Well, the truth is our human ear can't discern all that many sounds. I saw a thing, I was watching a making of, I think it was Fortnite, I can't remember what it was, but basically I remember it was some making of game making of thing, and they're talking about basic. Oh no, it was um the rat game. God, I'm playing it right now. Plague, Tale of Innocence. I don't know if you've played it. It's pretty cool. But basically, if you haven't played it, there's like basically these rats everywhere, and there's thousands of these rats, and so they're trying to manage how many rats. Because if you see one rat, it squeaks, but then you see two rats, two squeak, and if you see three, there's three different squeaks going on. These rat squeaks. But then as soon as you get like the scenes build up with like thousands of rats, well, you don't want thousands of rat sounds. So what they found is there's something like you can only discern like the footsteps of I think up to 3 or 4 things at a time. Same thing goes on in post production in film. So if you have like a group of 3 or 4 people walking, you have to sync up all the feet. But once you get above five people like walking in a crowd, like watch next time you watch like some movie and you watch like a scene where it's like a whole crowd of people walking, basically they're like disregard all the rest of the people, only do like sounds of 5 or 6 or 7 people, because your brain can't process and you can't localize that many different things at a time. So it makes sense for us to try to use that in our WWISE session here. So what we want to do is we want to limit the number of total sounds that are be able to be played. So what we can do is under our project settings here, we go to where's my project settings? Shift K. I should know that one. Shift K. We look right here. We see we have max volume instances right here. So right now we have 256 sounds available to us, and also a volume threshold. So what happens is if there's something that's below -80, and this is in decibels, if there's something that's below -80 dB, it doesn't play it. Because it's basically like, oh, that's so quiet. Because, I mean, in truth, so most of the time in digital audio, we talk about like -96. That's actual digital zero. That's digital zero for 16-bit audio. If we're going 24-bit audio, you can go much lower than that. But it basically is so what this tells us, so we have 80 dB of dynamic range from 0 to -80. So anything that falls below -80, like maybe you have some really, really quiet leaves rustling or something like that, that basically it's just going to turn that off, because it's like there's too many, you can't discern anything that's below -80. Well, we can actually, if we bump that up a little bit, so let's go to like, say, what did I have there? You -50. So if we go to -50 here, and you can do this for different systems. So if you're working on like, say, Switch or some of these more limited systems over here, you might want to, like, you're gonna reduce that. So basically you can multi-build for a lot of different platforms with the same sound set, and that's massive. So say you are releasing for PS4, for Xbox, well, I'll just say PlayStation, Xbox, Mac, Windows. Oh, who does Mac? We wouldn't do for Mac. So Windows and then Switch. That you would need to have different settings for all of these right here. And that's what's so cool, is that you can have it so you hit one button and it renders it all out for every single platform. So as the game changes, as your music changes, as your soundtrack changes, it's much easier to get everything sounding, keeps the chaos to minimum, makes you look good. But what you got to do, what you should do is though, when depending on how much your game developers know about Wise, they're gonna be like, okay, so we're gonna do this for PlayStation and for Switch. You're like, cool. They're like, okay, so we need to change this up. We need to change the dialogue settings for the game. You're like, oh, this is gonna be so hard switching it for all these different platforms. You got to bitch about it a lot, but actually, you're like, Switch done. But yeah, I mean, be honest, be transparent. But it's funny how some people, when they don't know the technology that we're using, they think some of the stuff that we do is so hard, and some of the stuff that they think we do is so easy. Like, I don't know. They're like, I know this is a big ask, but can you bring up that one little element just a little bit? You're like, yeah. You're like, that's so hard. And all you do is bring up a fader a little bit. But then there's other things that they're gonna be like, hey, yeah, can you just can you can you tune the second vocal in those ganged vocals? You're like, no, they're all in the same track. I can't isolate one vocal out of 10. They're in the same track. They're like, oh, come on, there's got to be a plugin for that. Like, no, there's no plugin for. Well, I mean, they try. There's ones like you can isolate like on a guitar string. You can isolate one guitar string on a thing. It's weird. Okay, so on this voice instance, what we're gonna do is we're gonna reduce that down to 40. So just because in truth, I mean, this is something to experiment with your actual game when you're playing it, but you don't know that. So 40 sounds happening at the same time, your brain processing that 40 sounds is gonna be, that's quite a bit. So what this is gonna do is by limiting the number of voices that are able to play at the same time, it's gonna really it's gonna keep the CPU cycles way easier. It's gonna make it a lot easier for the game to play. So at that point now we only have 40 sounds able to play at any given time. But how does it determine what sounds are played and what ones aren't? So in other words, if I limited it to 40 sounds, so anything quieter than that 50 dB, that will get cut off. That's cool. So those are just gone. But anything above that 50 dB threshold, if I have more than 40 sounds, how do I determine what sounds get cut off and what don't? Because what we don't want to have happen is the really key important stuff happening to that like it doesn't usually the way it does is like the oldest sound effect goes away. But the problem is if I have some sort of music playing or dialogue and that's clutch to the game, what I don't want to do is have the computer to accidentally go, okay, we have 500 sounds now, we got to cut some sounds out of here, kill the music. You're like, wait, no, that's really really important. So we need to set some sort of priority system on what to kill. So what we can do is, like in this case, actually, let's do the community as an example. We don't ever want the music to go away, like ever go away. So under our advanced settings up here, what we can choose is our priority. Or actually, so we can choose, well, first off, we can choose our sound instances to 50. Actually, let's do this on weapons. So on weapons right here, so we can limit sound instances to 50. So this is a further way of reducing this. So what we can say is 50 objects are only allowed to play at any given instances at a time. And it says per game object. And that's because what I'm working with right here is I'm in a actor mixer hierarchy. So what that says is this says per game object. So it's going to allow 50 instances of each of these objects down below here. But if I say globally, what that's going to do is that means I'm going to allow 50 of a combination of these below me. So when I say globally is a little bit misleading, but it means this one right here, that this is the global right here. And so only 50 below this thing are able to be playing at the same time. So if I'm shooting like some gun that shoots super fast, that basically it's going to limit the sound of 50 instances right there, and it's going to kill the voice by the oldest instance right here. So you can choose other stuff like use virtual voice settings. So this one kills it. We have these things called virtual voices. So if I go to virtual voice, so what virtual voice is, it doesn't actually play the sound, but all of the settings, like all of this stuff, stay in play. So it's managed, the CPU's or the computer's managing all of the sounds of like the what's happening with it, but it doesn't actually play it. So it doesn't actually have to do the processing and the CPU cycles for it. So basically it pretends it's there, but it's not. It's just not actually playing the sound, but it brings it back in. This one, it just completely kills it, wipes it off the map, and moves on. So yeah, so that's one way you can do this, like 50 right here. So the other thing is though, like with music, for instance, so this one I'm not so concerned if I lose. So in other words, if I'm playing a ton of sounds and I lose the last shot machine gun sound tail, whatever, I can't tell. It's going to be lost in the whole mix because I have so many other younger versions of that machine gun shot that's happening ahead of that basically it's going to swamp out any that tail goes off. You won't notice it. But with the Cubase theme right here, this is one where like I never want to make sure that this ever goes away. We cannot have the sound go away here. And that's where we have playback priority right here. So the priority is from 0 to 100. Default is at 50. And everything is set at 50 by default. So if there's something I'm like, well, I could get rid of some of the monster noises. I could reduce those, like monsters. Maybe like some of these death. I don't care about the death of these ones so much. So I could reduce those ones. Well, I guess those are set. I could set monsters. I could bring these down to say 30. That means they're lower priority. And then I'm gonna go back to my music, but I'm gonna raise this one to 80 because I'll just type it in. Because I never want that one to go away. And so if you never, ever, ever want it to go away, you set that to 100. But be careful with 100 because then you're all the way peaked out. So I would still do stuff like dialogue and music as higher priority, then sound effects, and then things like ancillary characters like the monster deaths and that kind of stuff. You can put those lower on the list. And maybe some of the guns. Well, actually the gun stuff we can put lower on the list too. So, and then maybe on monsters, I would say limit instances to, maybe bad guys. We'll limit instances that to 20 per game object. Actually, let's do this as globally. So I can only hear 20 monsters at a time. And so these are ways to like optimize your CPU. So that's good. Those are just kind of the strategies that we're looking for here. It's kind of this combination of limiting. Well, we're just limiting the number of voices and thresholds and also playback priorities. So that's a pretty good strategy. It's tough to manage. It's kind of hard to see everything happening at the same time. So how do we see all the stuff at play? So the next order of business is we want to actually like look at how this thing is working. So let's go back over and let's actually set up. Yeah, let's get Cube running right now. Cool, run around. So obviously it's working because we have sound effects in there. But what we want to do is we want to let's load up a different map, the one that has actually the stuff that we need. So start SP map. And if you haven't played it, there's a bunch of different maps in here. It's pretty cool. But DCP core that enters. So this is the DC. I don't know, like this DCP thing. It must stand for something back in the day when they made this game. But if we bring this game in right here, now we hear. Oh, actually, let's get out of here for a second. I didn't actually render this. This is the new version. This is the newest version of that. So let's go to F7. Save everything. Generate all. Cool. So no warnings. We're looking good. Let's go back into play. So this is going to implement the sound effects that we just created. Let's go back to single player. Start SP map. DCP the core with enter. We hear the music playing in the background right there. So now we're implementing all of these settings that we had going. But let's go back to WWISE. And actually, I want to move this to the left a little so I can watch what's going on here. All right. So what we want to do now is let's go over to the profiler, or what is it, F8 I think is. There it is. Yeah, I can never remember that one. That one's tough for me. F6. So we want to connect to the game. So let's connect. If we hit the connect game, we can see that it's running. Yes, connect. And my profiler starts up. I'm gonna move this over to the side a little bit. Squeeze it up just a touch. And now if I go back to WWISE. So we can actually, so we can see this is our bus outputs right here. Number of voices total and number of voices physical. So this is like the physical voices. These are the ones like when it goes to virtual voices, this includes virtual voices. This includes only the ones that are being played. But we can also see what's being played in our voice graph up here, which is pretty interesting. We can just look at streams, CPU, the CPU, how much it's hitting right there, listeners. Yeah. But the voices graph I think is pretty interesting. Voice bus is actually pretty interesting too, but stick with stuff like that. Look at voices graph. So we can see what's going on here. We have right now the teleport is playing in the background, but it's as a gain of 0 because we're not close enough to it. So basically it's using that dynamic, the distance thing. So when I'm far away from it, it's really quiet. As I get closer to it, this will rise up. And then we also have my cube main theme is at -9 right now, and the heartbeat is playing, but it's at -infinity because we have of our RTPC that's adjusted to our player health. So when the player health reduces below 50 or something like that, that's when it starts to fade in. So it's playing, we just can't hear it right now. And also you can see that the high pass filter is at 100, meaning it's all the way swept down. So with a high pass filter at 100, meaning it's swept all the way to 0. So as we get hurt, that will move up there. So we can also see the actions here. If we want to filter these out, we can actually watch just we can filter out just the states, events, switches, and all that kind of stuff. But right now we don't have any errors, so this is actually pretty useful. It's when we were doing it earlier in the game, we saw all those little red errors going by. So this is a really good idea when you're playing the game, making sure that you don't see any red go by. If you see red go by, that means there's probably an error. All right. So we can see in my graph down below there that we can see that it's only playing one voice. But let's switch over to shotgun. So you can see everything as they die, as the sounds die, they vanish. But I also like I can't. My mouse isn't. Well, here, I guess I can show it. So we also have a peak limiter right here, which is kind of interesting. So that's something that we hadn't seen before. And if you look right here, my shotgun, it peaks out there. So that means that it's a highly dynamic sound. So they're throwing a limiter on there. So if we go actually over to our gun sounds right there, and that was on the bus. It's on master bus. General settings. Effects. We see that there's actually a WWISE peak limiter right there, and we can actually adjust our threshold, our ratio, and look ahead time and release. So it's basically just a limiter, which it's kind of like working in music. That's actually probably a pretty good. Oops, not that window. 6. That's probably something that's pretty good. So let's go shoot some bad guys. There was that Tom sound.
Intruder alert.
So we can see our number of voices jumps through the roof right there. We have a lot of things happening right there. So as I'm running around, you can watch just my footsteps build up. Hit steady state, but I'm just gonna run. I'm trying to look at the graph. Come on.
Drainage system access granted.
There's a bad guy there. Yeah. Thought I saw something off my left. All right. So, and then I'm gonna hit escape, or actually, I guess I could just go over to this and stop capturing. And you can go back and look at what happened as the game was playing. And you can kind of monitor what's going on here, number of voices. So we can see that, we only had 15 voices going on right there. I have the limit set to, what was that? I had it set to 40, I think. So we have a limit on there. We never hit above this right here, but I think this will auto normalize. So as our number of voices go up, this will actually stretch over to it. But this is a really good way for us to, oops. For us to identify what's going on in the game. Actually, I think this is useful with 2 monitors, and actually also if you have somebody else playing the game, it's pretty useful. Sometimes with games, you can actually create a dummy version that plays itself, so you can actually just watch what's happening there. But you can go through and look at the log and go, oh, wait, what happened there? Missing material for brick. Global message. I don't know what that is. Does it give us a break that out? So it might be worth looking at. Oh, that's for that's visuals. So that's an error from the game. Yeah, those are visuals. There's no missing. They're missing some texture stuff. Oh, there's a red one. Event ID not found. So this is I don't know what that's. We'd have to figure out what that's from. But event ID. If you recall, if we go back in here and I look at say just a sound, when I create an object right here, when I create an event right here, the name itself up here is what creates this event ID right here. So I don't know what you could actually convert back, like it says event ID. I'm sure you can figure out there's an event ID decoder, so you can say what the event ID actually was the name of, and you can go back. You're like, oh, I don't have an event made for that. That's a problem. I accidentally missed. Maybe I typed the name wrong over here or something like that. Because if I typed this with the DSP enter without an underscore and I did a space, then it's not gonna have the right event ID, and so therefore it may mismatch. So you have to do a lot of sleuthing, go back and forth, and work out those little problems. Let's see, global entity ID not found, failed posting event, fireball monster. Oh yeah, so I'm sure. So this one it says event ID not found, and it said couldn't post this one. So end fireball monster is the one that's missing. So we'd have to go back like, why is end fireball monster not triggering? Oh, I didn't make it, or I misnamed it, or something like that. So that's pretty much the name of the game there. So at this point though, that should be enough to really get you going there. This is like stuff that you have to think about early on in the game, but it massively impacts. So when we think about the designing of a game, or it's the game sound, it's like this massively, not massive, but it's a sequential process. But we have to think about it kind of in a circular fashion because we're always about doing more with less, more with less, more with less, more with less, and so it's an iterative process. I guess it's same concept with music, but done a little different. So we'll call it there. You should have enough information now to like wrap up the seven. And actually, if you want to go through and actually take the finish up with your the quizzes, but the whatever the lessons, and then if you want to consider taking the actual 101 exam. But we'll go through this a few more times before you actually want to hop in and do that. But maybe might consider that. Cool. Have a killer weekend. I will see you later.